We are doing the chapter Atoms and Elements, in which we have discussed what are atoms. So atom is the smallest unit of an element, or atoms are the building blocks of matter. There are three subatomic particles in an atom, that is proton, electron and neutron. The charge on the proton is positive, the charge on the electron is negative, and the charge on the neutron is neutral. Atoms are the smallest particles of matter. We cannot break down further by chemical means. Okay, so we have studied that in an atom, if you remember the example of football stadium, it is your atom, and the nucleus is the P. So you can see how small the P is, how small the size of P is as compared to the atom. So in the center, we have a nucleus which is very small, and there are protons and neutrons in the nucleus, while electrons are there in the shells. Okay, they are revolving around the nucleus. So every atom of different elements, they are different from each other. Sodium atoms are different, diamond atoms are different, mercury atoms are different. So I told you diamond. What is the name of the element of diamond?
It's carbon.
Yes, it's carbon. Very good. So silver, okay, silver is an element, gold is an element. We have seen at the periodic table in the yesterday's session. Everything in the periodic table are your elements. Okay. Now when two
Even
atoms,
copper, right?
yes,
Even copper is element.
yes, even copper is an element. In the periodic table, you have copper also. Copper is also an element. Okay, and what is a molecule? When two atoms combine together by a chemical reaction, it is called your molecule. For example, H2O2, two atoms of oxygen combine together, then it becomes your molecule. Element.
Yes.
So what is the definition of element? It contains only one kind of atom. Very simple definition, right? No hard and fast theory here, that element consists of only one type of atom. Sodium is made up of sodium atom, so it is an element. Then we have discussed about the periodic table. There are 18 groups in the periodic table, 7 periods are there in the periodic table. Okay, and you can see the zigzag line which separates metals to the non-metals. Metals are present on the left-hand side and non-metals are present on the right-hand side. Okay, if I talk about the chemical properties of a particular group, so they have a same chemical properties. Chemical properties of lithium, sodium, potassium, they are same. Okay, because they belong to group 1. Similarly, chemical properties of nitrogen, phosphorus, arsenic, they are also same because they also belong to group 5. Okay, if I say the chemical properties of boron and silicon, they are different because they belong to group 3. Boron belongs to group 3 and silicon belongs to group 4. So they are different. Okay.
Yes.
Till now, any doubt?
No.
Okay. So this is your question which you have to solve, that which element has this symbol? Ca. So this is your homework question. This is your homework question. You have to solve it at your home. 3 questions are there. Which element has this symbol? Question number 2, see if you can pick out an element named after the famous scientist Albert Einstein. Okay, there's an element which is named after Albert Einstein, which you have to find from your periodic table. Question number 3, from the periodic table, name 3 metals, 3 non-metals. Okay, so you can easily tell 3 metals, they are on the left-hand side, 3 non-metals, they are on the right-hand side, but they behave in a similar way. So that means they belong to the same group. Okay, so write down your homework question.
Should I take down the homework on my notebook?
Pardon?
Should I write down the homework on the book?
Yes, you have to write down your homework in your notebook and leave space for the answer.
Okay.
Answers you have to write at your home. Very good. So yes, we have studied, we are doing the chapter atoms and elements. So we should know what is actually inside the atom. So I have told you that atoms consist of 2 parts. One is your nucleus, which is very small. This is my nucleus. This is my nucleus,
Yes.
okay. And these are my electrons which are revolving in the shells. Electron shells in which electrons are revolving. Okay, so I told you proton. Relative means comparative charge, comparison to other particles. So proton is positive, so it is positive 1. Neutron is 0, neutral, it is 0, and electron is negative 1. So if I ask you the relative charge, then you have to say proton is +1, neutron is 0, and electron is -1. Where are the protons found in the atom? You have to answer, ma'am, it is in the nucleus. Where are the neutrons found in the atom? You have to answer, it is in the nucleus. If I ask where are the electrons found in the atom, so you have to say in the shells, electron shells. Is it clear?
Okay. Yeah.
Draw this table.
What?
Draw this table in your notebook. The relative charge of the particle.
Okay. Only the diagram, right? Or
You can draw the holes. You can write down the whole slide so that it's easy for you. For now, I'm saying draw this table because it is easy for you to remember that the charge on the proton is +1, the charge on the neutron is 0, and the charge on the electron is -1. This diagram I haven't explained you yet. Let me explain. You have to. There's a rule in my class that you have to sit with your periodic table in my class. Okay. So carbon atom. What is the atomic number of carbon atom? That means how many are the number of protons in the carbon atom? So see the periodic table here. Carbon atom. Here is the carbon atom. Here. Can you see?
carbon. Yeah.
Yeah. So it is written like this. It means this number is known as your atomic number or proton number. One and the same thing. Proton number or atomic number. It means the number of protons which are present in the nucleus of an atom. Okay, so carbon atom have 6 protons. Carbon atom have 6 protons. If I ask you how many protons are there in the carbon atom, so you say 6. If I ask number of electrons, how many electrons are there in the carbon atom? So always remember that number of protons is equal to number of electrons in the neutral atom. Neutral atom means when there is no charge. Okay, 0 charge. Remember, when there is no charge, then it is number of proton is equal to number of electron. So carbon atom is neutral. Okay. There is no charge. So how many electrons are present there?
In carbon atom, there are wait, a carbon atom is neutral, right? Carbon atom is neutral, right?
Yes.
So then it is 0.
No, number of electrons. See here, it is written that number of proton is equal to number of electron in the neutral atom. You know the number of protons are 6 here. Then number of electrons should be
6.
Yes, 6, because number of proton is equal to number of electrons. Now, how to calculate the third subatomic particle, number of neutrons? So it is also very easy. You just have to use this formula: mass number minus atomic number. Mass number minus atomic number. Mass number is this. This is the mass number, the superscript. Okay, and this is the atomic number. So 12 minus 6 is equal to 6, right?
Yeah.
So we have find out that there are 6 protons and 6 electrons and 6 neutrons in the nucleus of a carbon atom. So you can easily now draw it. See, number of electrons are how many? 1, 2, 3, 4, 5, 6. 6 electrons are there in the carbon atom. And see, here it is written, it has 6 protons and 6 neutrons. So this is the atomic structure. Okay, by seeing the element, you can easily draw it. Is it clear?
Yeah.
Okay. Now, whatever you feel like, you can note it down in your notebook. Let me just
Okay.
Or you can draw like this. You draw a carbon atom. This is your nucleus. This is my first shell and this is my second shell. In the first shell, draw 2 electrons. I am representing it by a cross. 1, 2. And in the second shell, draw 4 electrons like this. And in the nucleus, simply write down 6p and 6n. That means 6 protons, 6 neutrons, and electrons you can easily count. But remember that this is only for carbon atom. And write down this thing also, carbon 612. 6 is your atomic number. and 12 is
Okay,
your
okay,
mass number.
okay.
One more thing, write down this thing, that number of proton is equal to number of electrons. These things are very important, okay? Number of protons is equal to number of electrons in the neutral atom only, when there is no charge. And one more thing, number of neutrons, if you have to calculate, it is equal to mass number minus atomic number. So copy this and then we will solve one question.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So let us do this for the oxygen atom now. Okay, so you are not having your periodic table with you right now, right?
Yeah.
Okay, so from next session, you have to sit with your periodic table. So let me tell you, for oxygen, it is represented like this.
What should I do for the periodic table? Should I like print it?
No, you have it in your chemistry books. I think
Oh,
it.
okay. I don't have a chemistry book right now. I just have
Okay.
biology.
Okay, so it's I am not saying that you have to take the printout. You can take the image on your phone. Okay, just Google it, the periodic table. So that's, otherwise I have to show again and again the periodic table. So it becomes difficult for me. If you have your periodic table, then it is easy for both of us. Okay. Or you can
Okay.
print it out. Okay, so there's no big issue. You can print it out also. Okay.
Yeah.
Yes. So you have oxygen atom. I am just telling, this is your oxygen atom O. This is my what? Proton number or atomic number, and this is my mass number. Okay.
Okay.
Tell me the number of protons here.
Uh, 8.
Very good. Tell me the number of electrons.
8.
Very good. Oxygen is neutral. You cannot see any charge. It is neutral. So number of proton is equal to number of electron. Tell me the number of neutrons.
The number of neutron is 8.
Yes. It is 16 minus 8, which is equal to 8. So very good. I hope you understood how to calculate number of protons, electrons, and neutrons if you are given an element symbol. Okay, now see, this is your oxygen atom. You can count number of electrons: 1, 2, 3, 4, 5, 6, 7, 8. There are 8 electrons are there. Okay, and in the nucleus also, it is so congested, but there are 8 protons and 8 electrons in the nucleus. Okay, there are 2 electron shell. This is my first electron shell and this is my second electron shell. Always remember, in the first electron shell, it has the capacity of containing only 2 electrons. It cannot contain 3 electrons. Okay, it only have the space that I can give space only to 2 electrons. Okay, this shell is known as K
Yes.
shell. Okay, it have only 2 electrons. Next, the second shell is known as L shell, and the electrons, maximum electrons it can hold is 8 electrons. Okay, so in the first shell you have how many electrons? 2 electrons, and in the second shell you have 6 electrons in the case of oxygen atom. So if you write the electronic configuration means how the electrons are arranged in the various shells of an atom. So you will write 2, 6 for oxygen. Why? Because there are 2 electrons in the first shell and there are 6 electrons in the second shell. So this is how to write down the electronic configuration. Is it clear?
Yeah.
Okay, so can you label this atom?
Yeah, done.
Okay.
What?
Now you have, can you label this atom? You can see
Yeah.
here there are 4 fill in the blanks. Okay, so tell me what should be in this fill in the blank.
That one, it should be protons.
Very good. Tell me what should be here in this blank.
Nucleus.
Yeah, very good. Tell me what should be here.
Neutron.
Amazing. And what is here?
Electron.
Good going. So as I told you, these are my subatomic particle summary, which you have to remember: their location, their mass, and their charges. So proton, where is it located? Inside the nucleus. Neutron, where it is located? Inside the nucleus. And electrons, where they are located? In the shells. Their mass of proton and mass of neutron is approximately equal. Okay, mass of proton and mass of neutron, it is approximately equal. If you see the exact values, okay, then mass of neutron is slightly greater than mass of proton, but in your level, in your chemistry class, you can say that mass of proton is equal to mass of neutron. An electron, its mass is negligible, it is 0. Okay, it is very, very, very light from as compared to your proton and neutron. So you can say its mass is 0. I am talking about relative masses. Relative means in comparison with the other particles, and I am talking about the relative charges in comparison to the other particles. So relative charge, I already told you, proton is +1, neutron is 0, and electron is -1. Okay, so what you have to remember from here is that mass of proton and mass of electron are equal, whereas the mass of electron is negligible. Is it clear? These are your relative masses and relative charges. Exact values are different. If you see the exact value, it is 1.67 into 10 raised to the power minus 27 kg. For proton, for neutron, it is also same, 1.67 into 10 raised to the power minus 27 kg. And for electron, it is very, very small. It is 9.1 into 10 raised to the power minus 31 kg. These are my exact masses.
Should I take down all of this?
All of
Like
this
the
means,
full table?
No, you know where is the location of these subatomic particles? If you don't know, you can write it down so that you won't forget. We have discussed the location and charge, right? Only mass is left. But if you want to draw, you can draw the entire table. These are your exact masses and exact charges.
Okay.
Sorry, exact charge is this: plus 1.6 into 10 raised to the power minus 19 coulomb. And for neutron, it is 0. For electron, it is minus 1.6 into 10 raised to the power minus 19 coulomb. It is a unit of charge, coulomb, which is represented as C, capital C.
Yeah. Teacher, should I take down the red part?
Red part, it's your wish. It is exact charges. Okay, yes, you can write it down. Exact charges also. These are my relative masses and relative charges. And in the red pen, you have your exact charges. It is also easy to remember because proton and neutron relative masses are same, 1.67 into 10 raised to the power minus 27 kg. Only electron is different, that is 9.1 into 10 raised to the power minus 31 kg. And by looking at these values, you can imagine how small the electron, how lightweight an electron is as compared to proton and neutron. And the charges are also very easy. Only you have to remember one value, that is 1.6 into 10 raised to the power minus 19 coulomb. In the proton part, you have to add a positive charge, and in the electron part, you have to add a negative charge. And neutron is 0. So yes, you have to write down this also. These are my exact mass and exact charges. And if I ask you in the relative mass and relative charges, then you have to answer as 1, 1, and 0.